We're on page 125. We're talking about graphical transformations.
I hate
And
transformations.
this is something that we've seen again and again and again and again and again and again and again. So you'll be a little familiar with this already. So one way that you can transform a graph is by shifting it vertically or horizontally. What's that? The forest is your... Okay, so like I said, we've seen this before. So if you want to do a vertical translation, if we start with a simple function like y equals x squared, how do you shift it vertically? Yeah, you can just add something onto there. Or if you wanted to shift it down, then you can subtract something from there. Okay, mildly more complicated is shifting it to the left or to the right. What's the difference then? Right, then you need to do it inside parentheses. So if I said x plus a inside the parentheses and then squared it, this would shift my graph good left a unit. Because recall that when the translation is inside the parentheses, it shifts it the opposite direction of the sign. So plus a moves it to the left. And if I wrote minus a, then that would shift it to the right. All right, then you can also take the graph and reflect it.
Raiders and Chargers?
Yeah, but always and they're really
Oh, because the Hawks got married by the worst team in the league. No.
Our Rams won't beat a lot.
Hey, Hawks got 4-0 there. Okay.
Oh, God. They're 4-0 the first.
Okay, if you take all of the y values and make them negative, then that will, and I'll do a couple examples of these in a second so you know what the heck I'm talking about. Then this is kind of like the in parentheses thing. You would think that since you have changed the y values from positive to negative, it would reflect across the y-axis, but it actually reflects across the x-axis. So it's in some ways the opposite of what you might expect. And then if you take the x's and change their sign, then that will reflect your graph across the y-axis. Okay? Okay, you be quiet. We are learning. Shh. You got that copy down?
No. Yeah.
Let's start with the function.
After 18, and 1, and 1 things. What is this an example of reflections across axis?
Yeah. And let's reflect this across the x-axis first. Okay, so to reflect it across the...
Wait.
Okay, what do I have to do to reflect the graph across the x-axis? Change the y. So this is the y, right? Okay, so I'm going to rewrite that as negative y equals 5x minus 9 over x squared plus 3. But can I graph a negative y? No, I need the y equals, so how do I get rid of that negative there? Multiply everything by negative 1 or whatever, so y equals, where do you want the negative to, oh, thank you. where do you want the negative to show up on the other side?
The -3.
I mean, we can go minus and then go parentheses around the whole thing. Is that what you want?
Yeah.
Okay.
Is that easier?
Yeah, that seems easier. The other way you could do it is you could put the negative sign through one of the, either the numerator or the denominator. So you could make this negative 5x plus 9, or you could make it negative x squared minus 3. But if you just negatize the whole thing, then that will also work, okay? And so let's take a look and see what that looks like graphically. So we started with the, what was it, 5x minus 9. And I have to put that in parentheses because there's two terms on top of my fraction. And x squared plus 3.
Yeah.
I'll show you. So here's what the original graph looks like.
Wow.
Okay, yep, so that's a fun one. Let me get a different, there we go. And so we're trying to reflect this over the x-axis, right? So we took and we made the whole thing negative. So all I need to do there is just put a negative out in front, and then go parentheses, same thing.
So you're just making a whole lot of graph.
Does it do a negative one?
Nope, just one negative. If I do two negatives, both of them will cancel, and I'll end up with the same thing that I started with. And you can see if I graph that, there's the same thing reflected over the y-axis. Okay? Over the x-axis, sorry. Okay, you can dig it? All right, so let's do the same thing now, but let's reflect this over the y-axis. And this is a little bit trickier. Now I have to take every x in the problem and replace it with a negative x. So instead of being 5 times x, it's going to be 5 times negative x minus 9. And instead of being x squared, it's going to be negative x squared plus 3. So before we look at this graph, let's simplify that a little bit. Okay, so let's simplify this. 5 times negative x is negative 5x minus 9. Negative x quantity squared is going to be just plain old x squared again, plus 3. Okay, so that's how that comes out. And so since this x term was squared, the negative canceled. So really the only thing that changed was the 5x became a negative 5x. So let's take a look at that graph and make sure that that works. So I'm going to now graph parentheses negative 5x minus 9 divided by x squared plus 3, and you can see that it's the same as the original graph, but it's then flipped over the x-axis. Okay. I mean the y-axis, yeah. No problem.
That's nice.
All right.
Okay, so wait, why is the x squared positive?
Because negative x times negative x is positive. Negative times a negative is a positive.
It's alright, aside from that,
okay, then the other thing that we can do is we can do
vertical and horizontal
yeah.
stretch. I don't want to take it.
Oh man, why should you type it?
Can I touch this, Mr. Aldridge?
No.
Move forward.
Okay, so there's two different things we can do here. In the same way that when you do something inside the parentheses, that affects it to the right or to the left. If you want to do a horizontal stretch or shrink, then you need to do your work inside the parentheses. So the way the book describes it, and it's a little bit confusing when we're talking about is it a stretch or a shrink. If you divide by a number greater than 1, then this will stretch.
So it's just as long as it's
By a factor of c. If you divide by a number less than 1, then and you will shrink by a factor of C.
Just tiny.
And then if you want to go vertical,
I wouldn't know.
hopefully not surprisingly, you need to do that outside the parentheses. So you need to multiply the entire function by some number C. And if, same as before, if C is greater than 1, then it is a vertical stretch by a factor of C. And if C is less than 1, then it is a shrink by a factor of C. All right, so let's start with f of x equals x cubed minus 16x. And let's transform this graph into one where it has been stretched vertically by a factor of 3.
So you put the 3
So when you want to perform a vertical translation, is it inside the parentheses or outside?
Outside.
Outside. So all I need to do for this is take the entire thing and multiply it by 3. And I'll simplify that a little bit. And that gives me 3x cubed minus 48x. Okay? So let's take a look at those two graphs. So the first one was x cubed minus 16x. And then the next one we took and multiplied that by 3, so we have 3x cubed minus 48x. And sometimes these are a little bit more difficult to see, but there is, whoops, the original one, and then now we can't even hardly see the other one. Let's just change the window. I'm going to change my y's to be way bigger and smaller so I can see what's going on. Let's try negative 50 to 50. Okay, so there's the first one, now it shows up, and then the second one, you can see it's as if you took this point and stretched it, pulled it up here, so now this point up here is 3 times as far from the x-axis as this original point was there. And that's true of all of these points on the graph. If I chose that point right there, and then went straight up to there, this point here would be 3 times as far from the x-axis as the one directly below it, yeah.
Does the recording catch this?
Anything that happens on the screen comes up on the screen. I know, it's pretty cool. Okay, now let's do now let's do a horizontal shrink.
When are you just going to stop when we have like all these videos?
This last thing I have to teach. Okay, now let's do a horizontal shrink by a factor of 1/2.
Actually, now we're going to watch this video.
Over 1/2. Yeah. Yep. Just go watch this video today, and then I'll just walk around the room and say, "Shut up and listen to the video." No, I wouldn't. I'd sit at my computer with my iPad and play video games. Okay, so we're starting with what was it? X cubed minus 16x.
Yes.
Okay, so now since we want a horizontal shrink,
Inside.
what we need to do is, yeah.
I'm just going to take all your videos after you because I'm going to be teaching now.
Oh, there you go. There you want to do it. Yeah. Okay, we're going to replace all the x's with x over 1/2. Okay, but before we do that, let's have a little conversation about what x divided by 1/2 really is.
It's a shrink.
Correct. What's the easier way to rewrite x divided by 1/2? Really, it's 2x. Okay, x divided by 1/2 is the same thing as 2 times x. Okay, yeah. Well, because we want to have a horizontal shrink by 1/2. Well, I have to take all the x's and divide them by 1/2 if I want a shrink of 1/2.
Oh, thank you.
So if I want to stretch of 5, I need to take them all and divide them by 5. So then they would all be replaced with x over 5. Okay? Okay, so I'm going to replace all my x's in here with 2x's. So this would become, instead of x cubed, 2x cubed. And that would become, instead of 16 times x, then it would be 16 times 2x. So if you simplify this out, what is 2x cubed?
That's 416.
Nope.
9x.
Nope. Over 2.
6x.
Over 3. 8x cubed.
I knew that.
2 times 2 times 2 is 8.
Oh, I was going, no.
Yeah, you were doubling each time. It's just times 2, 3 times. Okay, minus 32x. So that's what our new equation would look like. So let's take a look at how that looks graphically. So this now becomes 8x cubed. And then what was it? Minus 32x. And so if you look at the graph of those, this is a shrink this way. So you should see that all of these things are half as far away from the y-axis as they were before. 8x cubed minus 32x. Okay?
Yes.
And like you guys pointed out at the beginning, we've seen most of this before. So
Oh wait, just throw.
yeah.
All right, and we're ready to roll. Each of the next one to go. Biggest time, biggest time. Okay.
Is that the same times 3?
Yeah, so you have to do problems 3 through 42. You have to do each one 3 times.
Every 3, I guess.
Do every third problem. So 3, 6, 9, 12, 15.
3, 6, 9.
Whoa,